by doing this problem because I wanted to do some questions we couldn't do last week, and then I'll start talking about physics. Okay, what'd you get?
39.5.
Okay, you're wrong. Okay,
seconds would be.
okay. So first, it says what? That it travels for 600. We have to find the velocity. It says that it travels 1,000 feet per minute. So since the velocity is 1,000 feet per minute, it has to travel 1 minute, 60 seconds, equals to 16.7 feet per second. So we know that the velocity, so the velocity equals 16.7 feet per second. We're looking for what the velocity in the x direction is, or y. And it says, we know that from the uniformly accelerated equation, velocity x plus axt, and this should equal to, what is velocity x? 16.7 feet per second. So 16.7 per second, we just, plug it in. What do we know? Acceleration is 4, velocity initial on the x, that's what we're looking for. We're looking for time. We know velocity initial x should be 0. So 16.7x divided by 4. So t equals 4.18 seconds. So that should be simple enough. But it's asking for how far it moves while it's there. So it's telling for delta x. So we just use a uniformly accelerated motion equation. Velocity initial x plus half of at squared. I know you guys are taking a test, so don't look at the board. So we're looking for delta x. You just plug in velocity initial is 0, acceleration is 4, time is 4.18 squared, and then you should get what most people got, or around to it, 34.9. That should be simple enough, right? Like just plug and chug uniformly accelerated motion equations. Not too special, but the reason I chose this question was for part B, for how long does it take to make the run, starting and ending at rest. So the elevator has to accelerate to reach its constant speed, and it goes, it's constant, and then it eventually has to slow down, right? So, these two have to, time intervals equal the same, and we're told that acceleration equals 4, that's what we know, so acceleration equals 4.00 feet per second squared, and we're looking for how much it travels, how long it takes to travel. So we know that it travels 624 feet, and we know that from the earlier equation that delta x equals 34.9. So 34.9 up, accelerating, 34.9 deaccelerating, plus the 624 feet. So delta x becomes what? Delta x becomes 624 minus 34.9 minus 34.9, which equals to 554 feet. So that's how much it moves constant. This is how long it moves constant. So now we have to find how long it takes to travel at 0 acceleration, right? Because that's zero acceleration, so we do delta x equals half of, no, we don't even have to do this. We can do delta t equals delta x over v, because this is what velocity, the velocity equation. And then we just plug it in, which is 554 over 16.7 seconds for the velocity of constant, which we achieved in the beginning, and then it just becomes 33.2 seconds. So pretty simple. Just uniformly accelerating motion equation, since that's what we're doing. I just want to make it as simple. Also, I'm gonna start doing questions on the board to make it a little bit easier for you guys to see. This should be really quick. I'm just gonna give you like 5 minutes to do this one real quick, and then I'll make it. I'll explain it. Oh, sorry. I froze it. Here you go. Actually, I'll just explain this one because we don't have much time. So, we know that 11B. Yeah, okay, so we know that the train is traveling 102 kilometers per hour. So two trains are heading for each other. Right? Very cool trains. They're moving this way, this is moving this way. And then there's a bird. Right, there's a bird on here who's traveling to the train and back forth, right? So it says how many trips can the bird make from one train to the other before the train crashes? Let's try figuring that out a bit later, and first let's try out B, where it says what is the total distance the bird travels? So we know that they are 102 kilometers apart. So the bird has to travel, the train crashes at half of that point because they're traveling at the same speed. So it's going at 51 kilometers. It has to travel a distance, a total of 51 kilometers. And the trains are moving at what? They said it traveled at, where is that? No. What is it? Yeah, here. 34 kilometers per hour. So, using this, we can do 51 delta x equals, sorry, not delta x. Velocity equals delta x over delta t. And if we know delta x is 51 centimeters, then we can do, what? 34 equals 51 over delta t. So we can do delta t equals 34 times 51, or sorry, wait, no, I did this wrong. We can do 51 over 34, which equals to 1.5 hours. And then that's how much it travels. So back at this, so now we use this equation. So delta x equals vt, and we know it travels in 1.5 hours at a velocity of, the bird travels at what? 58 kilometers per hour, right? So delta x equals 1.5 times 58, which equals to 87 kilometers. So that's that. It's nothing special. But the thing I wanted to talk about was the second part, which was
Wait, can you explain how you got the 87 kilometers? Because
87 kilometers?
the time is,
So
I see what you did, never mind.
So delta x equals vt.
Yeah.
Earlier we figured out time equals 1.5 hours, and velocity is 58. So 58 times 1.5 is 87.
So it's like how much distance can the bird travel in 1.5 hours, basically?
Yeah.
Okay.
Basically, how long it travels before the trains crash, right? So simple enough. But what I wanted to talk about was the first part, which was A, which said how many trips can the bird make from one trip to the next before the same train crashes? So, if you know calculus, you might already know the answer, which is basically saying that the limit as two things approaches something, in this case it'd be what, 58 kilometers, it always has to travel half of the distance, right? It has to travel, to get to 58, the train has to go half of that, half the distance of 58. Not the train. The bird has to travel half of that, because during that time, when the bird is traveling to the train, the other train, the trains get closer together, right? So when the trains get closer together, then the bird has to can make another trip, but it's shorter. So he can keep doing that, and doing that, and doing that, but as the trains keep getting closer, as in like they get half and half and half and half and half or closer, they will always approach the 51 kilometer mark, right? They will always approach that 51 kilometer mark, but they will never hit it because the bird has to catch up with the trains, right? The bird has to go here, and the trains move forward, and the birds have to catch up to the train when it have the distance, right? So so it keeps going half and half, and the bird keeps having to travel and catch up and catch up. So what does that mean? Basically it means that the bird travels an infinite amount of time, right? Because the bird is always playing a catch-up game that he can never win.
Is there no definite answer?
Definite answer? It's infinity, basically. Logically, it's infinity. It's theoretical. Like, when you think about it, it's infinity. But in real life, you're like, the bird can't travel 58 kilometers per hour, and the train's always going to hit each other, right? That doesn't make sense. But it's a cool concept of understanding that values can continuously approach each other without ever hitting the value, which is basically the limit. Which I think is cool because I want to say that limits or approaching a value is the first step into how we found calculus. Now I'm gonna rant a bit, but So physics in Latin is physica, which is the study of nature, because some guy thought that physics was the supreme law of nature. So there's a video, we already saw it last week, so we'll skip that. To start off, the person who found that the limit approaches a value without ever actually hitting it was Zeno. He said that he found Achilles' paradox, and he was a Greek philosopher who basically said that as a limit approaches a value, when you approach a value, you can never hit it, which is how we understood and the first concept of limit. But during that time, people didn't know what limits were, or infinity, or how to use it. They just knew that a number's a number, right? How can a number keep going, right? That doesn't really make sense, right? So he was pretty told that he was a loser and to shut up. So he was told he was a loser and to shut up. So he was pretty insignificant during the time in the field of physics, or calculus in that matter. So René Descartes came along later, who, I don't remember which year, but he came along and he said a few new things about physics. Do you know what this guy did? Most famous thing? He's a philosopher as well. He said, "I think, therefore I am." You probably heard of it. Yeah, he's that guy. He's basically said, he said that, so he was like, he's a philosopher. He liked to think a lot. He had a lot of free time. He was white. So he looked at a graph. So he looked at two variables, like time and x, or like time and x. And he was like, he looked at those values like, how can you combine it? Or how do you use it together in the same way to make it digestible and readable? So, you have a question?
Oh, no, I finished that.
Oh, okay. So, he looked at it and was like, how can I make it look functional? Like how can I visualize this to a way where people can see statistics and values and numbers? So all he did was he drew a graph and he was like, oh, I put T here and X there. Boom, I did it. So he was basically, I mean, it seems so simple, but during that time, it was like the 1700s, like the 1600s, and this guy was like, he just put the numbers and he figured it out. So that's how we figure out,
In a couple of years, everybody's done.
thanks to this guy, we now know how to draw graphs for velocity and acceleration and delta x. So he found analytical geometry. And Pierre de Fermat, who is a French guy, and he basically said, and he was pretty irrelevant in the field of mathematics and physics, but he basically found the formula for limits. So if you've taken calculus or have interest in it, you've probably seen this before, right? Fx plus h minus fx, right? So you basically took what Zeno said and was like, what if you could find it and the value that approaches it? So he basically found it. So if you hate your Unit 1 calc test, blame this guy. So next, there was Galileo Galilei. You probably know this guy. This is probably my, I think this guy is pretty insane and crazy, because like, he found that gravity was a parabola, which doesn't make sense, right? Because you know, when you think of an object, it just falls, right? But he basically said that time moves in odd integers. So when time equals 1 second, the unit equals 3. And when time equals 3 seconds, the unit moves in 5 units. So it increases, right? So basically said that gravity is an acceleration, and it accelerates. Basically said that as long as it moves, right? But he was like, he had to figure out which time interval it was, right? But he didn't have a clock. It was like the 1600s or something. He didn't know how to keep track of time. So he used a bucket of water. He literally got a cone, poured water on it, and then he timed the drops of the water. Like, who does that? Like, this guy was out of his time, I think. And I think that's really cool. He was pretty much like, he was like, how do I keep time of stuff? Oh, I don't know, use a bucket. I don't really think like that. And then Newton, you probably know this guy, right? Pretty popular. You've probably seen his face everywhere, right? But this guy is insane. What is wrong with this guy? This guy was like, when he was 23, he had no parents. He was like homeless, and he barely got into college. And then he was like in his room, and then he looked at a graph, and it was like, yeah, if you just look at it, like, the y value is its rate. What? This guy had no parents. I have parents, I couldn't figure that out. This guy's insane. He basically said that the derivative of the rate at which the graph changes is its y value. Which, if you don't know integrals, that's fine. But basically he said that you can find the area under a curve. And he was like, and he also said, basically, that to find the area between 2 points of a graph, you just find 2 points, and then you just subtract them, which is, you just subtract them. These are just calculus fundamentals for integrals, but this guy was 23, looked at a graph, and by the way, his mother left him for a man, and then, I mean, this guy's sad, and then he got hit by an apple, and then he came up with, he literally changed everything. He literally changed all calculus, mathematics and physics, and now we use integrals for electricity, your computer, your TV, to find the volume of your backpack, to find anything really. And all he did was just look at a graph, and he was 23. I can't do, I'm not 23, but I can't do that. Like, that's insane. And then obviously the most popular one is that he got hit by an apple, and then he was like, the apple fell, but why doesn't the moon fall, huh? Like he's like at the moon, he looks at the moon, and he's like, why isn't that coming towards me and killing us? And he wanted to know why, so he found Newton's law of gravity to do calculations and figure out why apple falls. And
Can I interrupt you for 1 second? You told me to do a lab.
Yeah.
This would be the most amazing lab. Galileo's, you could try it next class. You know why? Because, I don't want to record it. He didn't have the motion detectors and whatever to measure the speed, so he slowed it down to where he could time it, and then he figured out the value of G like that. Make that the lab for next class, where they actually do it and figure out the value.
without a stopwatch or whatever it's
Yeah,
called?
without a stopwatch, because they had clocks back there, or they had
But
metronomes.
Galileo timed it with water.
Yeah, same thing. You could have a sand
Yeah.
clock or something, not like
Yeah.
that. You could use a real clock, but you can actually, if you can derive the value of G by
Just do it
graphing,
without a sensor, right? Just
What's
do it,
that?
Just do it without a sensor.
without a sensor, yeah,
Yeah.
yeah.
There
Be
are-
like Galileo.
Yeah, you can find different ways to time yourself. So that's pretty much that. And then the other most popular guy for calculus is Gottfried Wilhelm Leibniz. Gottfried Wilhelm Leibniz. I just like saying his name. So this guy is popular because he also found calculus, but Newton also found calculus. So what did this guy do? Did he copy him? No, he basically did it at the same time as Newton, surprisingly. I don't know how that works, but he basically figured it out at the same time Newton, without ever meeting Newton, without ever seeing the things that Newton was. And he had parents, and he was rich, and he had friends, and he was cool. So this guy was a lot better than him, but supposedly Newton figured it out like a few years earlier, which is kind of interesting. Also, he published it, so he got credit for everything. So, yay! It's like the light bulb all over again. So, one of the first people to make an observation about the formation of the Earth and our molten core. So this guy was a philosopher, a mathematician, and a geologist. So he was the person to think like the Earth has a mini sun in it, which is pretty cool. Okay, there's a YouTube channel now. I want to upload videos weekly, and I have made a channel and it's all up. There's the first video is already on there. So if you want to, I'll upload it every weekend. And if you're confused, want to retry problems, or possibly want to catch up from last week, you can scan the QR and you can subscribe. I am not asking you to subscribe. I want you to subscribe. I'm kidding. It's also on the website where I'll update on as well.
You gotta say subscribe.
Subscribe.